Hi, welcome back to our programming competitions training series. I'm Chisan Liu again. Today, I'm not going to solve any of the problems available at the USACO website, but I will try to explain in generals about how the programming competitions is all about and how we should prepare ourselves for the competition. Okay, and let me fire up my slides. This will be the first time in this series you see slides. Okay, here is it. Okay, first of all, I have to acknowledge all these resources where I get the materials from, including this website, USACO website. If you look at section 1.3, it's about crafting winning solutions. And that's, of course, the famous competitive programming book written by the Halim's brother and the another two articles. Okay, you can go to the internet and then try to Google for all these materials if you want to look for the details. Okay, well, in general, what is programming competitions all about? Well, we are talking about how you can solve some of the well-known computer science problem. An important, very important point is you try to solve them as fast as possible. When we use the word solve them means you should be able to came out the solutions in the given time frame and in the given memories. They always give you a time limit and a memory limit. That's why when you say solve them means you pass through all the constraints, it gives you the correct answer, but you have to do it as fast as possible. The experience from the ACM ICPC is you have to solve as many questions as possible. Most of the time it's about 10, 11, 12 in 5 hours. So it's a marathon and you have to do it very, very fast. So it's challenging, but important. You need to solve them and no need to worry about software engineering, what is the best practice of the software engineering, what is the right way to declare a class. I think for the competition's point of view, you can put those aside and just focus on how to write a simple program. And important is if you can solve it and run it, test it according to your data, it's not good enough. You should be able to run it against the test data by the judge. So most of the time, the participants facing this problem, my program is running correctly. I tried. It ran perfectly with my test data, but I always receive wrong answers from the judge. That means your program is not good enough. Maybe you break the boundary, you break one of the memory or the time boundary. Okay, and then try to do it as fast as possible and try to make your program run as fast as possible. And remember, these are not a particular research problem. These are very well-known problems. For instance, one of the ad hoc problem is about playing chess game, right? Find out what are the possibilities, how many combinations, how many possible moves for the pawn, for the knight, for the queen. Okay, so these are well-known problem, not research problem. Do it as fast as possible. So what are the skills that you need? The essential skills here including, well, of course, you should be able to write a very simple code. Okay, in your preferable language. But of course, you have to make sure that the language is provided by the organizer. For instance, for the ACM ICPC, you can choose to use C++, or you can choose to use Java. Okay, so these are the two languages provided. And for the USACO website, okay, you have to use C++. Understand elementary data structure. Depends on the language that you choose. Using and knowing how to use and knowing what are the available functions provided by this library is very important. You don't want to write your own data structures or your own sorting algorithm if the existing one is good enough to solve the problem. Of course, there are some exception cases where you need to write your own sorting algorithm, but most of the time using the standard library is good enough. So it means you have to know how to use these libraries. It's a must. Okay, it's a must. And well, a very common problem is the string manipulations. So make sure that you know how some of the basic tricks with the string manipulations. Otherwise, you're on the losing side. Okay, importance including the first, the I/O formatting. Some of the time you have the problems, not because of your program is wrong, but you don't know how to produce the right output that match the judge's output. They are doing the string matching for the during the evaluations. Okay, they will run they will use your program and then run the standard input, and they will get the output produced by your program and then do a string matching, string compare with the standard or the expected output. So even an additional line will make a difference. Okay, make sure that you know how some of the string libraries and the tricks, how to play with the tricks, and some of the basic algorithms for doing a character sequencing, character alignment, and how to do a fast searching in a string, and how to do some others, a string concatenation, string compare. Okay, and of course, sorting and searching is a very basic skill that you should know. Yes, as stated here, most of the time, those standard library is good enough, especially the sorting program. So if you use a STD libraries, you can use a sort program for any of the classes available for the set, for the list. And same for Java, the Java collection framework allow you to use the collections.sort method to sort it. Okay, well, doesn't mean that you can get away from implement your own sorting algorithm. Sometimes you need to write it, as I say. So make sure that you know how to write it as well. So next, we move on. Well, you go in, they give you the questions booklet. You open it up. There are a lot of questions there. So what to do the first thing? There are different approaches here. Our experience from our students before is some they will just tell the first questions, give one to solve it, while the remaining looking at the other questions. It will work. Some will actually skim through all the questions first and figure out which one is the easiest one to solve. Okay, then they only tackle the problems. So actually, suggest the idea is try to look at all the questions, because of who knows the last questions is a question that you have solved before or similar. Okay, so what you need to do is sketch the node with no algorithms about how to solve this problem and roughly estimate the complexity. If it is too difficult and there are too many constraints, like for instance, the time limit is 1 second with a memory about 1 meg, and you are not familiar with this problem, this means the hint is, well, you better skip the questions. And then order the problems. See which one you can do it, you do it first. Then only go for the next. Okay? And then for each of the questions, what you need to do is try to brainstorm many possible solutions. Because of sometimes you immediately, one of the ways of the possible solutions will come into your mind, but it might not be the right solutions. So try to brainstorm, think about all the problems that you have solved before during the training, see which one that actually will work, and of course the easiest to do. And then you try to code it. And of course, you want to, more important at the end of the day is whether can you beat the test case by the judge. So you have to define your own, design your own test case. It must be very complete. And for instance, if they say the data range is from 0 to 1 million, make sure that your case include all these possible combinations. Okay, if they say the maximum use case will grow up to 1 million and you only test up to 500, then very likely later you will get a time limit exceeded errors. Okay, so once you have your test case, the next thing to do is break the solutions that you just think of. So well, better for you to break it rather than the judge to break it for you, right? Once the judge break it and send it back to you, there will be a 20 minutes penalty if you go for the ACM ICPC. Those who have participated in the past competition, then they will understand better. Okay. Of course, the next thing is you want to do is you want to verify, is it correct? Important about the test case, you try to figure out, think from many perspectives. And if let's say 3 of you or 1 of you design the solutions, maybe your members will try to figure out, design a particular test case that actually can test it. Then you will think of some of the aspects that you have, well, overlooked. Then once you get the answers, what you want to do is you try to refine it, and then when you're happy with it, you think it is the answer, you submit it. Okay, what you can do next is pray that it will work. Otherwise, you get the errors, you try to debug it. Debug is something very, I wouldn't say it's a very pleasant situation, especially in such an environment where you need to solve so many questions and given so less of time. So what you need to do is, well, in the situations where time is running out and you will still have a lot of questions to solve. So what you want to do, you cannot end up with debugging these questions endlessly. you won't be able to afford to have 5 hours on a single problem. So then the next question is, when should you move on? Okay, well, some of the suggestions here will say, well, maybe you can think of how long you have spent debugging already. If you think you have spent too much time on it and you had lacking of idea and you couldn't see the bug, you don't know what's wrong. Is it the algorithm's wrong, or the data structure is wrong, or actually it's just gone wrong and you don't know what is it? Then maybe it's a clue for you to move on to the next questions. Okay, but make sure that you write down all the things, all your observations with these questions, because of when you come back and when you have time later, you want to revisit these questions, those will be helpful. You won't start it from, you don't need to starting it all over again from scratch. Okay, so this is very important. Or perhaps you might give it a go, give it to your friends and ask your friends to solve it. And here are some of the tricks and tips compiled by those teams and those experienced coach. And well, brute force it when you can. Easiest way to solve the problems, but not always will get the right answer. Otherwise, it won't be that fun, right? And of course, keep it simple, stupid. Try not to think something very complicated unless it is necessary, because most of the time, it is much easier than you think. Okay, focus on limit. This is very important. Time limit, if they say it's 1 second, make sure that you can run all the test case in 1 second. Okay, and the memory limitations as well. And well, if there's no memory limitations, well, you can afford to have a different way, like for instance, loading the entire data set into the memory, or do whatever pre-computation is if it is necessary. And during you do the debugging, you might have some output, some comment it. Well, those will be useful if the answers didn't turn out to be the right solution. Then you need to look at those, you need to debug it again, and then you might need it again. So you just comment it. Okay, important, very important, before you submit your answer, make sure you remove all the comment. Otherwise, you're losing another 20 minutes penalty. And well, optimize this, of course. If you come out solutions, you're not very happy with the performance, this is what you should do. And the last thing, keep all working versions. This is important. Okay, when you want to you will try to branch down into, you think that you can optimize it in such a particular perspective. You try to go down to, the lane, but you figure out, oops, it is not. You hit the dead end. You want to come back, but you already lost the previous working versions, and then you have to do it all over again. This is something that you don't want to have during the competition. And some more tips. I think this is from, if I'm not mistaken, from the Halim's brother. Code to debug. White space is good, meaningful variable names, don't reuse variables, stepwise refinement. So all this, even those we mentioned in the earlier slides, we are not worried about the software engineering. But if you use some variables, even yourself cannot figure out what is it all about, you will suffer later when you try to debug it. Okay? And yep, comment before code. Like I did in the first training, what I've done is I start with writing all the code. Sorry, I comment down all the steps, the pseudocode, and then I try to write the code one after another. It is helpful, okay? Especially, it is more readable, and then it's help you to organize your thinking. Okay, these are some of the solutions paradigms suggested on the USACO website. Means there are some general paradigms on solving the problems. Like for instance, the first one, mentioning about generating versus filtering. Generating, if let's say they want you to find a sequence of permutations, example is find a sequence of permutations that follow a particular pattern, like 2, 4, 6, or 3, 5, 7. And if you have two ways to do it. One is you generate all the possible permutations and you filter out those not relevant. Okay, this is called generating and then filter it. So of course, filtering is easier to develop and faster to do it. But because of you're generating all the possibility, so most of the time, well, I would say it's definitely slower. But of course, if you have a time limit constraint, then you have to spend more time on how to generate using the right formulas, the right code. Okay, so again, depends on the situations. If you allowed to host the entire data structures or entire record, then, well, you might want to pre-compute it, generate it, and then use it later. Like, for instance, sometimes if you need to do a matching between some characters and value, then you can create an array, store all the characters and all the values, and then you can do a very fast lookup. So this is another trick as well. So, well, more solutions paradigm coming in. Decompositions. Well, if you have solved all the easy questions in the competitions, then of course they will save a few of those, I would say, killer questions, and where actually it needs more than one problem-solving skill. So for these kind of problems, what you need to do is you try to break it down into a smaller problems and then solving it one after another. These are considered very tough questions. So I think if you, well, depends on which level you're going. The experience our students from the previous competition is, if you go to the national level, you should be able to come across these questions. But if you go to the regional, well, you're still busy with the first few questions after 5 hours. I'm sorry, but this is what happened last time. Okay, and symmetrics. If let's say they give you a graph traversing algorithms, then what you want to do is, or some of the answers can be find it out a symmetric way. Okay, the distance between the 2 points. Okay, and well, some of the others solution paradigms, including all the time we are solving the problems from front to back. Well, some suggested sometimes you move backward from back to front might be easier. So try, if you can't do it, then maybe try to process the data in the reverse order. That's a good hint. Okay. Well, the last one, simplification. It's very unlikely you will see a problem exactly match what you have done or what you have solved before. So it won't. But sometimes with some minor modifications, some changes, removing some of the parameters, you figure out it becomes something that you have done it before. In that case, try to do a simplifications of the problem and break it into a smaller problems, then you might be able to find a full answer. So this is one of the tricks. Okay, you look at the questions, try to match and think about, based on your experience, have you solved this problem before? If you have not solved it, but have you seen it, a similar problem before? If yes, can you do a simplifications and try to solve it? Or in other words, you never see this problem before, and maybe it's a good hint that you should move on. Well, of course, you need to practice. What we are doing all this series is basically we try to smoothly preparing a ramp that bring you to ease your training so that easily for you to get up to speed. And what you need to do is practice, follow all the questions, if possible, all the USACO questions, solve all the problem. And because of when you look at how other people solve it, you won't be able to remember it. Okay, more important is you will learn a lot of tricks when you try to solve one single problem. So try to solve those problems. Even though you won't see the same problem come out again in that competition, but at least you have polished your skill. Okay, and well, if you're talking about ACM, ICPC, these are the types of the problems that you might come across: ad hoc, complete search, divide and conquer, greedy, dynamic programming, graph, mathematics, string processing, computing geometry. You can either master all of this field, or you can have a composition of a theme that each one of you mastering 2 or 3, or you might just want to focus on half of them and forget about the rest. Okay, depends on the levels you are targeting. Sometimes, well, our experience tell us the champion might only be able to solve 6 out of 10 questions, and if you know how to solve that 6 question, you're already the champion. Okay. And then, yep, again and again, mastering a programming language. You don't need to be a top programmer in order to take part in all this programming competition. But at least you should be, I would say, competent enough to write a basic program without looking at the reference. Okay, you know how to very fast and then read from the file, and then how to loop through all the records, and then how to move on from one to another. So these are considered basic. And I have seen some of the Wolf finalists, they share their experience, they mention about they are writing a lot of their own macros and shortcut. Like for instance, a for loop, instead of for us writing the for and then open, close parentheses with the details inside, they have write their shorthand. So they can use it very fast. Because one of the hints given by the Halim's brother is try to type and try to write as fast as possible. Okay, so you might want to consider. But if you're just a beginner, well, you can skip this and focus on others training. And bring your own code. For all the programming competitions, the ACM, ICPC, either national, regional, or world, I'm not sure about world. I think it should be the same. You can bring your own cheating sheet. Means that your own code. So sometimes it's helpful that you bring your own classes, your own library, your own data structures. And if you need to use it, then you can use it. Okay, but well, if the given std libraries in the C or the Java standard packages is sufficient enough, then use it. Okay, well, this is important, very important. Equal important, I would say, to writing a program. You should be able to write a solution and you should be able to test whether is it valid. So you should learn how to prepare the test case. Okay. Again, don't leave the testing to the judge. You're losing marks. And I think this will be the last thing about practice. You should enhance some of your theoretical background. For instance, in the mathematics, are you familiar with some simple arithmetics, some number theories? How do you modulus? Because of our experience from the past few competitions showing that some of the very simple theory is needed. But if you don't know, then I would say you're on the losing side again. And make sure that you know some of this basic algorithm training. If you follow the USACO website, the USACO training site, I think you will learn all this. Okay, all the basic problem-solving techniques and graph theory. Can you find the shortest path? Geometric, computing geometric. So these are all the basic, I would say, very crucial things for you to understand. Of course, the next thing, well, I think the last slides will be what you want to do next. Form your team. Okay, and there are different strategies in order to form the teams. You want to follow the Americans or follow the Russians or follow the Chinese approach. Some they will try to get the 3 top programmers together and then and then make that into a team so that they can equally have the same capability to solve all the questions. Some they just get the best programmer and the best problem solver, well, and the best test case designer together to form a nice team. And it's up to you. But once you have your strategies and your formations, the next thing is you should start your training. There are a lot of repositories out there for you to use. We start with the USACO training. Another good resource will be the UHunt. And for those, just try to polish all your programming skill and not really depends on the language that you use. Try with the Project Euler. You can use even Python and Perl script, whatever scripting language you can use. Okay, of course, if you're prepared for the ACM ICPC, make sure you experience with the PC2. I think it stands for Programming Competitions. Sorry, I forgot.
PC square.
Yeah, go to Google it out and and then try to download it. It's very easy. You will just spend less than half an hour to install it. Okay, my experience, I have experience with this and set up a lab with 20 PCs to use it. Should be able to set it up very fast and then try to run it. Okay, and there is another website, but I couldn't recall it now. Well, so my last message: work hard and good luck. So I guess that's all for this round. Thank you very much.